Okay, hi everyone. So we're going to be continuing from where we left off, high heat of vaporization. So water has high heat of vaporization, which means it converts into vapors, and when it absorbs heat, it converts into vapors, right? So the amount of heat required to convert a unit mass of liquid into gas is the like heat of vaporization. And water, the number of calories absorbed per gram vaporized. That's how we represent the heat of vaporization in water. And it's 474 calories per gram. You can see it's pretty high. And the high heat of vaporization means large amount of heat loss from your body. And that's why we sweat. That's why we sweat and release the heat to the external environment. Sorry. Okay, so the animals would like sweat. The horses, the humans, everyone sweats or pant and release the heat in the environment through through you know water, evaporation of water, panting or heat release to the ears. Sorry, not the air. So an evaporation of just 2 milliliters of water would reduce the temperature of the remaining 998 mLs by 1 degree Celsius. So you can see that's pretty high amount of like temperature. 1 degree Celsius, just 2 ml of water. That's pretty high amount. Now let's see the hydrophobic exclusion, which means water does not mix the hydrophobic things like oil. Oil is hydrophobic. Hydro means water and phobic means to be afraid of, to avoid. So hydrophobic things avoid water like oil. Okay? So when you drop the oil in water, so many drops of oil will just join to become one oil, or sorry, one drop. Okay, not one oil. Okay, and it plays a key role in maintaining the integrity of lipid bilayer membranes. So our membranes, our cell membranes, our nuclear membranes, our membranes of the organelles and everything are just made up of hydrophobic, or not hydrophobic. They're made up of phospholipids, which means one had its sorry. There's a hydrophobic head and there's a hydrophilic tail. The head is made up of the head is hydrophilic while the tail is hydrophobic. So yeah, PO4, it likes to dissolve in water, while the fatty acids do not like water too much. Okay, so that's why lipids just stay, just lipids won't let water. Okay, now let's move on to the next one. Ionization. Ionization means to dissociate into ions, like to split into ions, like for example a sodium and a chlorine when dissolved in water would like split into ions, sodium plus and chlorine minus. There's a negative charge on chlorine and a positive charge on sodium. So water ionizes to release an equal number of positive hydrogen and negative hydroxyl ions. What's a positive hydrogen and negative hydroxyl ion? You see this, going to be drawing an equation. It's a reversible procedure. Sorry, a reversible reaction. H plus and OH minus. This OH minus is basically uh, it's basically hydro, not hydro. It's basically the hydroxyl ion, okay? And this is the hydrogen ion. And hydrogen, H plus and OH minus ion would just take part in so many reactions. For example, it would help to maintain or change the pH of the medium. Like you can see when you study the chapter bioenergetics, how like H plus ion influx or deflux would create, like it will create I don't know, I can remember the word. Yeah, it will create a concentration gradient, and sometimes it will provide acidity, like in our stomach. The H plus ions would provide the acidity. That's okay. So the reaction is reversible, and when is it reversible? It's when the temperature is at 25 degrees Celsius. The density of water is okay. So after the ionization thing, we've got the lower density of ice. So ice floats on water. And ice floats on water because it's less denser than water, right? Liquid water. So ice has a giant structures and it has many hydrogen bonds between the water molecules, and it arranges itself into a lattice, which makes a crystalline structure. And in freezing water, ice will form over pools and lakes, which creates an insulating layer above the water. And it provides living environment for some organisms until the ice melts. So on the right side, you can see a picture of the crystal lattice of ice, and on the right side, you can see the hydrogen bonds between water molecules and ice. Okay, so it's like a hexagonal structure. And the last thing that we've got to discuss is the protection. So water is an effective lubricant, and it provides protection against damage from friction. Well, I wouldn't say for all the bodily processing it's a good protection, but if we can see if it see the like eyes, it protects our eyes from the eyelids, and there are like cushioning of water in our organs. Tears protect our surface of eye, which is the cornea, from the rubbing of eyelids, and water forms cushion around organs and helps to protect from trauma. Trauma means like any sudden jerk or any sudden injury protects our internal organs. So with that, we've completed our topic. Thank you so much for listening to me. Bye.